Hello, everyone. In this video, I'm going to explain the parallelogram of forces. The concepts that are important, you must be able to define a force. A force is an influence that can change or tend to change the state of rest or motion of a body. Now, you also need to be familiar with the effects of a force on a body. A force can have a certain effect on a body that is at rest, on a body that is in motion. If an object is at rest, a force can move the object or it can try to move the object. If it is in motion, a force can accelerate it. It can try to accelerate it. It can decelerate it or try to decelerate it. A second concept is a system of forces. When two or more forces act on a point, that is called a system of forces. And a resultant force. A resultant force is a single force that can replace a system of force and still produce the same effect. Another concept is the equilibrant force. Equilibrant force is a single force that balances the system of forces. So the topic that I'm going to explain, or the concept, is the parallelogram of a force. The definition of a parallelogram states that when two pulling forces acting on a point can be represented in magnitude and direction by adjacent sides of a parallelogram. So when you are given this force and they are both pulling from this point, if these two forces can be represented by adjacent sides, so the red lines here are the adjacent sides of a parallelogram in magnitude and direction, the resultant of these two forces will be represented in magnitude and direction by the diagonal of a parallelogram. This is the diagonal of this parallelogram taken from the point on which forces are acting. So the direction of the parallelogram will be this way. The forces are acting at this point. So it's taken from the point on which forces are acting. Now let's look at the second slide on how to determine the resultant force graphically. The steps that you're going to follow, or the methods. First one, you redraw the given forces according to suitable scale. So if a force is pushing, you change its nature to pulling, because from the definition it says when two pulling forces, they must act away from the point. Step number two, you complete the parallelogram by sketching the adjacent side. Step number one, you sketch the given pulling forces. Step number two, you sketch the adjacent side. Step number three, you measure or you sketch the diagonal and measure the length. So the diagonal of a parallelogram, from the definition, the resultant will be a diagonal. So you measure the length of this line. It will be the resultant of these two forces. And the last thing, you measure the angle, at what angle, which is theta. Now let's look at the example. This is the question paper of November 2014. So let's have a look at this question paper of November 2014. The question is, determine graphically the magnitude and direction of the resultant force of the following system of forces. So we are going to use the method, the parallelogram of forces method, to determine the resultant of these two forces. From the definition, the parallelogram, the nature of the force must be pulling when two pulling forces. So what I'm going to do first, I will transfer this force because it is towards the point. So I will change the nature of this by extending its line and sketch it on the opposite quadrant. And this one, I'm going to sketch it as it is. So let me show you how to do it. The force is vertical, straight down. And it is 70 newtons. So I'll sketch a line. When the scale is not given, you can use any suitable scale. There is no scale given, so you can use 1:1. So 1 Newton can be equal to 1 millimeter. So that 70 Newton can be equal to 70 millimeter. So this line is 70 millimeters. The direction and arrowhead that represents the direction. This is the 70 newtons and the arrowhead that represents the direction. I will label it 70 newtons. So the second step now is to sketch the second given vector. This is 70 newtons. It makes 60 degrees from the vertical line. So I will measure this line using a protractor. This one makes 70. The angle it makes is 60 from the vertical line. 0, 10, 20, 30, 40, 50. This is 60 degrees. Then I'll draw a line. The magnitude of the second vector is also equal to 70. So these two are equal. I'll draw a line through that dot, which is also equal to 70. And an arrowhead that represents the direction. The next step from the definition, this is the second line, which is 60 degrees from the vertical, and an arrowhead that represents the direction. The third step is to sketch the adjacent side. To sketch the adjacent side, a side that is parallel to this 70 is going to start from this side. And the side that is parallel to this line is going to start from this side. So I'll just use a compass and take measurements on this line. This is 70. Even if you use a ruler, you're still going to get 70. Then I'll put this compass at the end of this line and scribe an arc. Scribe an arc. Since this is also 70, I'm not going to change the measurements on the compass, but I'll put this 70 Newton at the end of the other line. They are both equal to 70, and scribe another arc. So at the point at which these two arcs cross each other will be the joining side of this parallelogram. So I'll just use the straight ruler and pull a broken line or a dashed line from either side. This is to show that this one is the adjacent sides. The original diagram is solid and the adjacent sides is a broken line. From either side, I'm just pulling the straight line. So these two lines, this is parallel to this side and this is parallel to this line. Now the definition of a parallelogram states that the resultant will be represented in magnitude by the diagonal. So I will sketch a diagonal of this line and measure its length, taken from the point on which these forces are acting. So diagonal will be taken from that point to this side. Then I'll sketch a diagonal. The direction of is this way. So the resultant, this diagonal is equal to 70 millimeter, which is equal to 70 newtons because the scale 1 is to 1. The next step is to measure at what angle, to measure theta. So I'll use the protractor. If I draw a cross there at the intersection point of this, that is a Cartesian plane, and place a protractor there to measure that angle. This angle is exactly 30 degrees from this horizontal line to the resultant line. So from the horizontal line to the resultant line, the angle is 30 degrees. And it is below the left horizontal, which is west, is going to south. So this will be southwest. The resultant of this system of forces, R, will be equal to 70 newtons. And the angle is 30 degrees south of west. Now, if the question is looking for the equilibrant is force that brings the balance. Equilibrant is equal to the resultant but opposite in direction. I will just extend the resultant line 70 Newton. I pull 70 Newton from this side in opposite direction. This will be the equilibrant. And the direction of the equilibrant will be that way. And I label it E for equilibrant. It is equal to 70 Newton. It is equal to in magnitude, equal to the resultant in magnitude, but opposite in direction. If this angle is 30, also from this horizontal to the equilibrant, it will be equal to 30 degrees. So the equilibrant is also equal to 70 newtons, 30 degrees. This is southwest, the resultant is southwest. The equilibrant will be northeast. That's it. You can also be given a word statement like this one. The first question, this is the question paper of April 2018. It says, which are the two graphical methods that can be used to determine the resultant of two forces? The first method that is graphical is the parallelogram of forces. We determine the resultant of two forces. The nature when two pulling forces, there must be two forces and pulling. Another method, we can use the triangle of forces. You sketch a triangle of forces that will be head to tail and the resultant will be closing side, opposite in direction. This question reads as follows. Two forces of 60 newtons and 80 newtons respectively act at a point. The direction of the 80 Newton is 90 degrees east. So the direction of the 90 is given. 80 is 90 degrees east from the north. And the angle between the forces is 60. Determine the resultant of the forces graphically using a parallelogram method and clearly indicate the most suitable scale used. So a scale, you can have the given values, or you can sketch a bigger diagram using the values as they are. So to have the scale for this question, number 2, the scale can be 2 Newton equal to 1 centimeter. So that if you want to calculate 80 newtons, it will be equal to X. You cross multiply, X multiplied by 2 Newton will be equal to 80 newtons multiplied by 1 centimeter. And you divide both sides by 2 newtons. And you get your answer as 4 centimeter. It's 20 newtons, right? 20 newtons. And you get your answer as 4 centimeter. You divide by 20 both sides. Also, you are allowed to use millimeters by saying 2 Newton is equal to 1 millimeter. Then you put 8 this side and equal to X. When you cross multiply, this will be 80 Newton times 1 millimeter equal to 2 Newton multiplied by X. Divide both sides by 2 Newton, both sides by 2 Newtons. Then this X will be equal to 40 millimeter. So you can use the scale in centimeter, or you can work with millimeter or centimeter. Now let's look at this sketch. The question says the 80 newtons is 90 degrees east from the north. So from the Cartesian plane, this will be your classwork. You're gonna try this. This is north, east, west, south. So the 60 Newton, the 80 Newton is 90 degrees. From here is 0. From up to this point will be 90 when coming from north. So you're gonna have the 80 Newton this way. The direction of the 80 Newton is 90 degrees east from the north. And the angle between the forces is 60. So from here, you measure 60 degrees and you sketch the second force, which is 60 newtons. And you apply the method of parallelogram of forces. You apply the method of parallelogram of forces. This is 80 Newton east. You measure 60 degrees using a protractor and you pull a line that is 60 Newton or 6 millimeter or 3 millimeters since the scale is halved. Then you apply the method of calculating, determining the resultant. Thank you.